All right, in 6.4, we do a little more with polar coordinates and polar graphing, but specifically we're going to graph polar equations. And there's 4 different kinds of graphs you need to know how to write equations for and to create. It's circles, plain old circles like we're used to seeing. Then something called rose graphs, cardioids, and limosons is the last one, or sometimes people call them lemmasons. And you're going to need to know how you can certainly graph them on a graphing calculator. Or if you're interested in seeing a nicer graph and you have either a phone or something with internet access, the site desmos.com, and they have an app too, actually. But those actually do a nice job of graphing too. You just need to make sure that you click on the wrench in the settings there and change it to the polar grid instead of the regular grid. But ultimately, you need to know how to graph these by hand, and you know how to graph them without a calculator. So you'll need to know the rules. Next week, as we get closer to the test, we'll give you some information on kind of a little mini cheat sheet. But for the most part, you need to know how to graph these on your own just from the equation itself. So first, we'll start nice, short, sweet, and easy. If you graph the equation r equals some number, that is going to be a circle that's centered around the pole, the center of that graph, the origin. And the radius of that circle is just whatever the number is. So if I'm graphing r equals 4, then the radius equals 4. Nice, short, and sweet. If we tweak the equation, and instead of just equals 4, what if we take a number times the sine of theta or a number times the cosine of theta? So we're looking at kind of 2 slightly different versions over here. And so I'm going to graph in a second here. I'm going to pull up the graph of 4 different ones. What I want you to look at for a second and think about is, when you look at these graphs, what does k tell you about the circle? That number is going to tell you something about the size of the circle. And then these are all going to move around on the graph. They're going to be opening, or the circles are going to be in different parts of the graph. I want you to see if you can figure out what might tell you which side of the origin that circle is on. So here are our 4 graphs. The equations, this one right here, the equation is r equals 3 sine theta. This equation here, or this graph right here, is r equals negative 3 sine theta. And these two appears to there's some similarities and they're about the same size. It's a little bit hard to maybe read for you, but this graph goes out 1, 2, 3 units away, and so does this one. It goes down 1, 2, 3 units away. Down here, I have a slightly bigger circle. This one goes out 1, 2, 3, 4 units, or you can look at the 5 right there and see it's 1 away. And this time the equation is negative 4 cosine theta. The one on the right is 4 cosine theta, and again it moves out to the right. So if we look at these, what does k tell you about the circle? Well, the k is the number in front of the sine or the cosine, and in this case k is 3, and it's also 3 here. It's a negative 3 there, but the value itself is k. Well, what that 3 tells you is not the radius of the circle. In this case, that k is the diameter. It's the distance all the way across the circle, both here and here. So if you did want the radius, you'd have to take that number divided by 2. Otherwise, if you're just having to sketch the graph, you just need to know that that k number tells you the diameter. Then in the bottom, we have negative 4 cosine theta, 4 cosine theta, and we can confirm again that, okay, yes, this does have a diameter of 4, and this one also has a diameter of 4. The other question is, which side of the origin is the circle on? Well, the thing to look at or notice or pay attention to here is that these top 2 graphs both have sine. The bottom graphs both have cosine. Well, when we look at how these open, in this first one on the left, one of the ones with sine, the circle is, instead of being 0, like right on the center, it's been shifted up, or it moves up or opens up. When we have a negative sign, we switch and it moves to the bottom underneath the origin, or opens down. Well, when we do unit circle stuff, sine is usually tied to the y coordinate. So it turns out that if you have a positive sine graph, that circle's above. If you have a negative sine graph, that circle's below. Similar idea for cosine graphs. If you have a positive cosine graph, then that circle's just to the right of the origin on the positive side. If you have a negative cosine, it's over on the left of the origin where negative x values are. So here's what I would write down, and make sure you get in your notes or make sure you have internalized. This is kind of our generic rules. First, if you're graphing r equals k, that is a circle centered at the origin that has radius k. Not much else to it. If you have k sine theta or k cosine theta, then it's a little bit trickier. First of all, if it's k sine theta, it's centered on the y-axis, which means the y-axis cutting right through the middle. And if you have a plus version, it opens up. If you have a negative version, it opens down. For k cosine theta, on the other hand, now it's centered on the x-axis, and plus means right, that the circle's on the right side of that center point, and negative would mean to the left. So not necessarily anything too surprising, but at least we've kind of confirmed how to tell whether it goes above, below, left, or right. And then the other thing to notice when you're talking either of these kinds is that the diameter is k instead of the radius being k. And for these ones where you have sine or cosine, the radius is just that k value divided by 2. So just while we're here, we're going to do some practice, starting with if I was going to graph r equals 5. Well, anytime you have just an r number, or r equals a number, that's going to be a circle centered in the middle that is a diameter of 5. Or sorry, no, a radius of 5 for this kind. It's getting late, getting tired. So I want to go out 1, 2, 3, 4, 5. And I just need to trace around the edge of this, or along this grid line. Because my radius is 5 the whole way around the circle. That would be my r equals 5 graph. If I am going to graph, on the other hand, r equals 5 sine theta, well, first of all, the diameter now is going to be 5, not the radius. And then it's a positive sine graph, which means my circle is going to be between the origin in the middle here and straight above. And now when you draw these, you don't need to be perfect. Something like this is not going to be good enough. That is not a circle. Nobody would think that's a circle. That's not nearly good enough. But it's a little bit hard to get these perfect, so just kind of try and do your best, especially when your circle lines don't match up from the polar graph paper. So that's not perfect, but that's good enough. At least it's rounder like a circle. And then for this bottom one, we have r equals negative 5 cosine theta. The cosine means it's either going to be to the left or the right of the middle. The negative 5 means it's going to the left. So I technically would go from the center and then out 1, 2, 3, 4, 5 points. But that puts me right on the edge of that circle. And then I just need to get it drawn in. Oof. I don't like that one at all. Let's try this again. Definitely not perfect. But that'll be good enough. So it opens to the left because of the negative cosine. And that ought to wrap it up for circles.